Hello students. In this lecture, I am going to discuss about the different concepts of a structure of atom. Let's start with the Bohr's model of atom. Question asked here is of the following which statements or statement regarding a Bohr theory is or are correct. Okay, this type of question where the option is like more than one options are correct are asked in a JEE advance. Okay, sometime one option is correct, sometime more than one option is correct. I have chosen these questions so that I can revise a concept related to the energy of the electron. Okay, so here let's start with the concept. The question says that of the following, which of the statement regarding Bohr theory is correct? Like kinetic energy of an electron is half the magnitude of its potential energy with sign reverse. Okay, this is the first statement it is saying. Then second is kinetic energy of an electron is negative of the total energy of the electron. Like second statement is that. Then third is energy of electron decreases with the increase in the value of a principal quantum number. Then last is ionization energy of the hydrogen atom in the first excited state is negative of one fourth of energy of an electron in the ground state. Let's do it with the example, not an example. Let's understand this concept. Like energy, that is a potential energy, right? So energy, which is potential energy is equal to work done. One will be is equal to work done. Now, how do we do this? Like if we do the if we take work done is equal to like integral of like let's say from some distance infinity I'm getting it to some distance r. Next r is equal to r I am writing r infinity to r, and that force multiplied by force into displacement. This is a small displacement, right? Over here force which is there, it is a Coulombic, okay, Coulombic force. So for this force which is given, like force is given as r is equal to infinity to r is equal to r. Force I am substituting it to be kz e square by r square. Now, how we are getting this equation, right? How we are getting this equation? Like force is what? That force is between the nucleus, which is a positive charge, and it is between the electron. Like there is a force between this. So this force is given as k multiplied by like between two charges. Okay, Coulombic force between two charges is given as uh, q1 multiplied by q2 divided by r square, right? So this is how the Coulombic force is given between two charges. Q1 is the one charge, Q2 is the another charge, and the square divided by square of the distance. This is the distance, right? So here, let's say this is my Q1 and this is Q2. So what would be a magnitude of the charges? Like this is the charge, means it is the nucleus. Nucleus has the uh, protons, right? It has the proton. And here this is one electron. Let's say if I take a sodium atom, right? If I take a sodium atom, Na, then this is one of the electron, let's say outermost electron, and I am finding a Coulombic force between the outermost electron and the positive charge on the nucleus. So over here, the positive charge which is there on the nucleus, it will have a charge of Z into charge of electron, right? Magnitude I am taking. I'm not taking a sign of the charge, right? So it is Z is the atomic number. Let's say for sodium there are 11. 11 is the atomic number. So 11 protons will be there into the charge, like charge of the proton is same as that of the electron, right? But only opposite in the magnitude. So that's why one of the charge I am writing this as a Q1. This is I am writing as a Q1. What is Q2 magnitude wise? It is equal to just E. So I am writing this is equal to K Q1 to be ZE into E upon R square. This changes to this becomes equal to Kz E square by R. That is what how the force is defined. Okay, so let's go ahead from here. Now integral, if you see the this K is constant, Z is also constant, charge on electron is constant. What can vary is a distance. So I will take the integration. We don't apply integration on constant, so I will just integrate. Okay, also dr is there. Okay, this dr is there. I will just integrate 1 by r square into dr. So what I am getting as a potential energy to be is equal to kz e square as minus 1 by r is equal to infinity to r is equal to r, right? So which is equal to minus kz e square by r. This is your potential energy. U will be the potential energy. I will say that this is the potential energy, right? So total energy is equal to potential energy plus kinetic energy. Now how potential energy is given? Like potential energy is given as a minus kz e square by r. This is how the potential energy is given, right? And kinetic energy is half mv square, right? Now we need to substitute for this mv square, right? So whenever it is an interaction between the electron and the positive charge, what is there is I will say that a Coulombic force will be is equal to centripetal force, right? Centripetal force, because electron is also in a constant circular motion around the nucleus. So here kz Coulombic force, what I am getting by magnitude, Coulombic force by it is k z e square by r square I will get, isn't it? So here which will be is equal to centripetal force, which will be is equal to centripetal force is given as mv square by r. So this r and this r will get cancelled. Means what I am writing over here is mv square will be is equal to kz e square by r. So I will substitute into the mv square over here minus kz e square by r plus half the times kz e square by r. Now this is your total energy, which will be is equal to, this is 1 and this is half. So minus half the time kz is square by r. This is your total energy what we are getting. This is the total energy which we are getting. Now going to the question back, what is asked is I'll just kinetic energy of an electron is half the magnitude of its potential energy with sign reverse. Like what was the potential energy I was getting? I was getting potential energy to be this, right? This is the potential energy over here in this equation. And okay, let's take this equation. This is my potential energy and this is my kinetic energy. So what we can say is that by looking at this first statement, kinetic energy of an electron is half the magnitude of its potential energy with a sign reverse. Like it is having sign reverse and it is half of a potential energy. That's why first statement is correct, right? Kinetic energy of an electron is negative of the total energy. Now, what is the total energy we are getting? Total energy I am getting minus half kz e square, right? And the kinetic energy, what is the meaning of kinetic energy? It is half the time kz e square. So here this is also correct. Kinetic energy of a electron is negative of total energy of the electron. So this was the kinetic energy, right? This was the kinetic energy which is negative of the total energy. Energy of the electron decreases with the increase in a value of a total principal quantum number. Kinetic energy decreases. Now, total energy TE would be given as like minus 13.6 into Z square into N square electron volt per atom. And this is one of the way. One more thing we can represent total energy as like some other unit. If it is in joules, then 2.18 into Z square by N square into joule per atom. Like in both the cases, if you see, energy of the electron decreases with the increase in a value of principal quantum number. Like value is negative, right? Value is negative. Now principal quantum number represents a n value. Like n is equal to 1 first shell, n is equal to 2 second shell, n is equal to 3 third shell, fourth shell. These are the main shells, right? So 1 2 3 4, these are called as principal quantum number. Energy of the electron decreases with the increase in the quantum number. Like magnitude wise, like if this was not a negative, this sign, if it was not a negative, then this statement is true. But energy is negative, right? Energy is negative. With increase in the principal quantum number, denominator is increasing. What will happen? Since it is negative, this statement is also true. Like we have proved first statement, second statement. Sorry, this statement is incorrect. Energy of the electron decreases with increase in a principal quantum number. If you increase the value of this n square, then what will happen? Overall value will going to be increase. So this is incorrect statement regarding this, right? As the numerator increases, denominator is total value, overall value will decrease, but this is negative value, right? So that's why this statement is incorrect. Third, ionization energy of the hydrogen atom in the first excited state is negative of the fourth, negative of one fourth of energy in the energy of an electron in the ground state. Now we have to understand what is the meaning of the ground state and the first excited state. See, when it is a ground state, keep that in mind. Ground state means n is equal to n is equal to 1, right? And first excited state means n is equal to 2. This is what is the meaning of first excited state. So ionization energy of the hydrogen atom in a first excited state means it is n is equal to 2. So minus 13.6 upon hydrogen. So 1 upon, I am putting first excited state, n is equal to 2. So this will be 4. which will be is equal to, so is the negative of one fourth of energy of an electron in the ground state. Like in the ground state, n is equal to 1. So this is minus 13.6 into z is 1, and this is also 1. So if you see, this is minus 13.6 by 4, and this is minus 13.6. So ionization energy of a hydrogen atom in the first excited state is negative of one fourth, right? This is one fourth of energy of the electron in the ground state. This is the energy, like one fourth of this is the energy of the electron in the ground state. So option A, B, and D are correct.